When NOAA's GeoXO satellite is launched in 2024, it will be the final satellite in a heralded NOAA satellite program and a bridge to another future age of advanced satellite technology. For nearly 50 years, NOAA and NASA have partnered to develop and advance NOAA's geostationary satellites as part of the most sophisticated weather-observing, environmental monitoring, and space weather monitoring satellite system in the world. When GeoXO reaches orbit, it will be the culmination of nearly 5 decades of state-of-the-art geostationary Earth-observing satellites. It all began back in October 1975. For the launch of NOAA's GeoXO-1 satellite, which monitored our weather and space weather.
We've come a long way in weather forecasting since the early balloon launching days, thanks mainly to weather satellites. With each succeeding one, these weather sentinels have become more and more sophisticated. Here, the synchronous meteorological satellite. 2 are already in orbit, with a 3rd scheduled for launch this fall. The synchronous meteorological satellite pictures are made into film loops daily. Meteorologists are hopeful that this kind of information will give them clues to the weather conditions that, for instance, cause tornadoes and other fast-moving weather systems.
As groundbreaking as it was, it had limited capabilities and only viewed Earth about 10% of the time. By 1980, a new series of GeoXO satellites went into orbit. These satellites had the capability to obtain vertical profiles of temperature and moisture throughout the various layers of the atmosphere. This added dimension gave forecasters a more accurate picture of the intensity and extent of storms and allowed them to better monitor rapidly changing events and make more accurate predictions. In 1994, GeoXO-I was launched, and with it came significant improvements in the resolution, quantity, and continuity of GeoXO imagery and data, thanks to a new 3-axis method of stabilization. Once it reached orbit, it was renamed GeoXO-8 and gave forecasters more accurate information to pinpoint locations of storms, wildfires, and other hazards. By the mid-2000s, GeoXO-N, GeoXO-O, and GeoXO-P further improved the imager and sounder resolution to better pinpoint the locations of intense storms. This satellite series also had improved optics, better batteries, and more power, allowing for more continuous imaging.
3, 2, 1.
Then in 2016, the current generation of geostationary satellites was launched, the GeoXO-R series. With this series came new advancements that included state-of-the-art instruments like the Geostationary Lightning Mapper and the Advanced Baseline Imager, or ABI.
When we got the GeoXO-R, I remember sitting on the forecast desk and seeing some of the earliest data, and it was a game changer. An absolute critical part of our forecast process to see that ABI and actually track cloud movements and track how much moisture's in clouds. It was amazing. And it enables us to look at phenomenon like atmospheric rivers and be able to help us with the forecast for the flooding, the amount of rainfall. And on the front lines at the National Weather Service, we provide decision support. And so to have that information from GeoXO-R, it really enabled us to communicate information to decision makers for them to make really tough decisions.
Well, we knew the technology was going to be game-changing. We knew the ABI with its capabilities, and then the Geostationary Lightning Mapper, which was a brand new instrument. We knew that was going to be revolutionary. We even thought it's so new that there's probably going to be new applications, but the range of new applications that people have found have really surprised me. We found over time that ABI can detect turbulence, so it can really look at a patch of sky and see when there's going to be turbulence for aircraft flying through it. We've recently found that ABI can actually detect large methane leaks, so it can tell when something is going wrong in a plant, a refinery, and be able to track that feature.
Space weather monitoring has also been part of the GeoXO mission since its inception. So after GeoXO-U, what's next for NOAA's geostationary satellites? Its planned successor will be a state-of-the-art satellite series called Geostationary Extended Observations, or GeoXO. The first GeoXO satellite is expected to launch in the early 2030s as the GOES-R series nears the end of its operational lifetime. Like GOES-R, GeoXO will continue NOAA's 5 decades of critical Earth-observing data. However, GeoXO will have new technology on board. One of the new instruments will be an infrared sounder, which will allow weather forecasters to see the atmosphere in extremely fine detail.
It really looks at very fine slices of the atmosphere across a wide area so that it builds up sort of a 3D view of what the atmosphere looks like. And forecasters can use that information to be very precise about their forecasts, where a storm is going to be, how severe a storm is going to be. They can even do predictions of how much water, what the precipitation levels are going to be. So that's one new capability that our forecasters are really looking forward to.
The sounder will also help detect quickly changing wind speeds and direction, which will assist in everything from hurricane prediction to aviation forecasts.
So a big part of the National Weather Service's mission is to forecast for aviation, for safety, and also looking at that fuel economy, looking at detecting the direction of the wind. So that capability is just going to be absolutely amazing for aviation and earlier detection and quicker detection of tropical systems when it comes to rapid intensification.
There will be 2 other new instruments on GeoXO as well. One will be an air quality instrument that will monitor and track harmful air pollutants, including wildfire smoke and volcanic gases. It will provide continuous observations and measurements of atmospheric composition, which will help improve air quality forecasts and alerts across the United States. Another instrument will measure ocean color, which helps detect and track threats to our lakes and ocean, such as harmful algal blooms and oil spills. Perhaps most critically, NOAA's GeoXO will also meet new needs for the data user community, including forecasters, researchers, and others who depend on receiving crucial environmental information across the Western Hemisphere. Data from GeoXO will contribute to weather prediction models and drive short-term weather forecasts and severe weather warnings.
These users are looking for advanced capabilities, and they've told us what they want to see in this next generation, which is going to start observing in the 2030s but continue into the 2050s. And with the changes on our planet and with the society's increased reliance on environmental information, it's really important to be able to serve this wider variety of needs.
GeoXO observations will allow scientists to better monitor environmental conditions and will complement observations from other satellites from NOAA, NASA, and our international partners. This will help them to address emerging environmental challenges, respond to the effects of Earth's changing climate, and improve forecasting and warnings of severe weather and environmental hazards.